Welcome back to the Advanced Microcontroller series. In this session, we are learning about microcontroller interfaces with SSDs. And here is the agenda: Introduction, Design, Circuit on board. So this is the 7-segment display. So it having 8 segments, but we are considering 7 segment in most of the time. So it is called 7-segment display. So we considering A, B, C, D, E, F and G, 7 segments. So we having one more segment, that is DP, means decimal point. So here array of LEDs connected internally. So here you can see this is the LED. So here LEDs are connected internally. Possible configurations are common cathode and common anode. Very good line of sight, and it is used in many applications such as electricity, metal. This is the design. So here you can see these are the LEDs. So this is what LED array. So LED is having two terminal, anode terminal and cathode terminal. So here you can see all cathode terminals are commonly connected to ground, and this terminal is connects to the microcontroller pin. So since here all terminals, cathode terminals are commonly connected to ground, this type of SSDs are called common cathode circuit. So to turn on this particular LED, what we need to do? We need to consider that particular pin as high. So to turn off this particular SSD, what we need to do? We need to consider that particular pin as low. But here you can see this is what anode terminal, isn't it? All the anode terminals of all LEDs. So here we having so many LEDs, right? So all anode terminals is connected to VDD, and this cathode terminal is connected to the pins, microcontroller pins. So to turn on LED, what we need to do in this condition? So we need to consider that particular pin as low. So why? Because these are cathode pins, right? But this is anode pins. So to turn on LED, we need to consider the particular pin as low. To turn off LED, what we need to do? We need to consider that particular pin as high. This is the condition for common anode circuit. So here you can see we having 4 SSDs. 1, 2, 3, 4. So how many interfacing lines are there? For one SSD we having 8 interfacing lines. For 4 SSD we having 32 interfacing lines. So for 4 SSD we having 32 interfacing lines are required. But our microcontroller is having 40 pins, right? So what we need to do? We not prefer to connect all 32 lines to the microcontroller. So here all 4 SSDs are commonly connected. So here we having A. So in this SSD we having A segment that is connected to the A segment of another SSD, like that, commonly connected. So what will happen now? My aim is to display 1. So what we need to do? But here all 4 are commonly connected, right? So here to display 1, what we need to do? A, B, C. So we need to consider this B and C as high. So then what happens here? This will turns on. Similarly, this also turns on, and this one also, and this. But my aim is to print 8051 or 1234 or 4567. So what we need to do to print different numbers? So what we need to do to print different number? So to avoid this, so here we using control lines. So here like that, for this SSD we having one control line, and for this also we having control line. Similarly we having 4 control lines. Similarly we having control line for this and this and this. So here we having 4 control lines. So here you can see. Now if I put 0 here, this particular SSD turns on. So why 0? Because it is common cathode connection, right? That's why. So here control pins are current sourcing circuit or current sinking circuit. That is sinking current, right? So when you turning on all LEDs, so okay, so here we considering all the segment pins, and here I am turn off all the control pins. So now what will happen? The total current is flowing in control pin. So here I selected only one, right? All currents are flowing like this. So here we having so many segment pins, right? So all the currents are flowing like this for this particular pin. So what we need to do, there may be a chance of short circuit, right, due to high current. So all current is flowing in one control pin, that is this one, right? So what we need to do to limit the current? So we need to add current driver. So what we use here? So I am using transistor, not resistor. So here we need to use the transistor. See here, this is the transistor. So this is NPN transistors, okay? So instead of making current flow in this direction, what it will do? Be making this flow towards the ground like this. So to turn on to turn on this particular SSD, what we need to do? We need to consider this particular control pin as high, and also this transistor, this pin also high, to turn on the particular SSD or display. Now to make on display 2, what we need to do? We need to consider RA3 as high, and this transistor we need to consider it also high. So here we having control lines. So these are connected to RA2 to RA5. So these are the output pins, and this is the data lines RD0 to RD7. So this is what port D, right? So this is also output pins. See here, so 0 0 1 0 0 1 0 1, and here we selected C2. C2 means this one, right? C2 means this particular SSD is selected. So now this is common anode connection, right? So 0 means it turns on that particular LED. So here A is 0, sorry, so here A is 0, then B is 0, C is 1, D is 0, E 0, F1, G 0. Sorry, this is what, 2, right? This is 2. Similarly, write this. So here C3 is high. Okay, I am not going to write it here. So I'll just erase it and I'll write here. So C3 is high. So A is high, B is low, C is high, D is high, E is low, F is high, and G also high, and DP is low. So see here, this is 5, right? So here you can see this is 2 and this is 5. So this is C3 is high, that's why it is 5. So we need to, at a time we need to show both, but we can't show C2 and C3 together, right? So what we need to do, we need to make it to faster. So here you can see 2 and 5. So at a time we can't show, right? So what we need to do, we need to show, we need to increase the frequency, right? So here we having delay, we need to increase frequency, then it will show together. So otherwise what will happen, first 2 will on, it takes some delay, 5 will on. So we need to increase the frequency. Okay, let's write the code, but before that let's discuss about the code. Okay, so here in common cathode, to turn on, what we need to do, we need to consider the particular pin as high. So here we considering port D. So in port D we having 8 bits, right? RD7, then we having RD6, then we having RD5, sorry, then RD4, RD3, RD2, RD1 and RD0. We having 8 bits. So this RD7 is connected to DP, RD6 connected to G, then RD5 connected to F, RD4 connected to E, RD3 is connected to D, RD2 is connected to C, RD1 is connected to B and RD0 is connected to A. Sorry. Now I want to print 0. How I will do? So to print 0, what we need to do? So here, so to print 0, so in this, here what we need to do, we need to consider this particular segment as high, and this segment, this one and this one, then this one. Now it is 0, isn't it? So here which segment are high? A, B, C, D, E, F. Except G and DP, rest all segments are high. So here you can see, except these two, all segments are high, isn't it? So here this one 0 and this one 0, rest all should 1. D, C, B, A, all should 1. 0, 0, 1, 1 means 3, right? So 1, 1, 1, 1 means F. So here you can see 0, 0, 1, 1 means 3 and 1, 1, 1, 1 means F. So this is what? 0, X, 3, F. So for 0 we need to write 0, X, 3, F. Similarly, we need to write for 1. So for 1 what we need to do? So here we need to consider this particular segment high and this one, means B and C are high. So here what we need to do? 0 and this one also 0, 0, 0, 0, 1, 1, 0. 0, 0, 0, 0 means that is 0 only, right? For 1, 0, X, 0, 0, 1, 1, 0 means 0, 1, 1, 0 means 6. That is what? 0x, 0, 6. Similarly, we need to write for 2, 3, 4, up to 9 we need to write. Same thing you need to follow here. So now, for the control pin. So here we having control pin 4, right? C1, C2, C3 and C4. So, and here you can see RA2 to RA5 we considering the control pins. So for control pin here we using tris A, port A. So port A is having 6 bit, right? But here we having 4 control pins. So what we need to do? In port A we having 6 pins, 6 bits, RA5, RA4, RA3, RA2, RA1 and RA0. But here we considering RA2 to RA5. Rest other pins are not considered here. So 0, 0, 0 means what? 0. Then 0, 1, 1 means what here? 0, 1, 1. That is 3, right? So that is what? 3. 0x, 0, 3. So here we using AND operation. And so now what we need to do? 0x, 0, 4. We need to use the shift operator here. So here what you will get here? 0, then 0, then so before that, okay, let me write below. Before that we need to write this one 0, 0, 0, 0, then this is X and this one X. So now here we considering shift operation, shift operator 0x04 shift operation. So now here 0 0 0, then 1, then again 0, so next 0. So what you will get final? Port A and 0x03 or this shift operation. What you will get the final? 0 0 0 1, then you will get X X. So this will make only RA, this one RA2, right? RA2 is equals to high. So what we need to do to make RA3 equals to 1 or high? So here we need to shift this one. So the same thing we need to do, but here we need to use 1. So then what will happen here? You will get 0 0. Here you will get 1. Here you will get 1. Why? Because here you need to shift, right? So here it is 1 and this is 0 only and this is 0. So here you can see all are 0 except RA3, right? RA3 equals to 1. And next RA4 equals to 1. What we need to do? Left shift by 2. Here left shift by 2. Then 3 for RA4. So similarly we need to do. Okay, let's write the code now. Open the MPLAB X IDE. And also open the PICSimLab Simulator. Yeah, so in the MPLAB X IDE, I am not going to write the code again. So here I am going to click open project, and here I am having SSD project. So click open project. So here we having source files and we also having header files. So this is the code. So here you can see this is the logic. So here what will happen? Here you can see SSD of 0. Now my aim is to print 8051. So now my aim is to print 8051. Here I need to write 8051. So in this SSD of 0 I need to write, then this line will display the SSD values. So here you can see max SSD count. So here we having 4 SSDs, right? So that's why max SSD count is 4. And here we using port D for SSD data lines, and control lines we using tris A. The same thing you need to write for 0, 1, 2, 3, which I explained earlier. And if you want to print ABCD also, write the same thing for this also. This is what SSD.H and this is the SSD.C. So here you can see setting the SSD data lines as output 0x00 and setting SSD control line as output. So here you can see this one, and SSD control port equals to SSD control port and 0x03. So here you can see for loop condition for digit equals to 0, digit less than max SSD count and digit value is incremented. Then it will print this line under this condition. Okay, let's build the code. Build is successful. Open the PICSimLab Simulator. Here click File, Reload. So here load hex SSD, follow the path, then so here why it is printing like this? So here you can see, so because here I written 8051, right? Instead of writing 8051, I need to write 8 like this, EIGHT. The same how I written here, the same name I need to write here, 8055 then 1. Sorry, by mistakenly I written like that. Okay, so here click save, then click build. Now build is successful. Come to the PICSimLab Simulator, click reload last. Now here you can see 8051, but here still delay is there, right? So what we need to do? We need to change the value of delay. So here I am writing 400 instead of 4000. So let's see what will happen now. Go to the file, then reload last. See here there is no delay, right? Yeah, this is the output. So that's all about the microcontroller interfacing SSD. For more project, please watch the upcoming videos. Thank you all.